Hello, viewers. In today's session, we are going to discuss another important and conceptual problem from a domain of functions, right? So here we have this problem in which we have to find the domain of this function f of x, which is equal to log of greatest integer of x, right? So here we are using the notation that is log for the natural log, right? So here the function log of greatest integer of x can also be written as ln greatest integer of x, right? So let us start. So now to get the domain of this function, here we'll make use of the definition of greatest integer function, right? And we'll also draw some important conclusion to arrive at the domain of this function. So let us take these important points one by one. So the first important point is that the greatest integer of x should not be equal to 0, right? So greatest integer of x should not be equal to 0 because when greatest integer of x is equal to 0, then we have log of 0, and log of 0 is it tends to a minus infinity, right? So here we have to avoid all those values of x which makes greatest integer of x is equal to 0. Now to understand this point, what we will do, let us draw the real number line, and here we have 0 and here we have 1, right? So whenever we have x lying between 0 and 1, including 0, then for all values of x which lies in this interval, that is 0 to 1, the value of greatest integer of x is equal to 0, right? For example, if we have, say, x is equal to 0 0.5, then 0 0.5 lies between 0 and 1, and the greatest integer of 0 0.5 is equal to 0, right? So here the first important point is that the greatest integer of x should not be equal to 0, or in other words, x is greater than or equal to 0 and less than 1. So we should not have any value of x which lies in this interval. So now the second important point is that here we have greatest integer of x, right? And this x must be greater than 0. Or in other words, we can say that x should be a positive real number, right? So we can easily discard all the negative numbers, because the greatest integer of the negative numbers will give us a negative number, right? Now let us take some examples here. Suppose we have, say, x is equal to say minus 1, right? Then we have log of greatest integer of minus 1, and the greatest integer of minus 1 is minus 1, and here we have the logarithm of a negative number which does not belong to the set of real numbers, right? So here we have to avoid all the negative values of x, so it implies that x should be greater than 0, right? And we have already said that x should not be equal to 0, right? So now using these two important points, we can now easily arrive at the domain of the natural log of greatest integer of x, right? So in the first case, we have said that this x should not belong to this interval, that is 0 to 1, right? So we have to discard this interval, that is from 0 to 1, and here 0 is also we can eliminate x is equal to 0 also, right? Okay, and x is equal to 1 may be taken because log of greatest integer of 1 is equal to log of uh, greatest integer of 1 is 1, so log of 1 is 0, and 0 belongs to the set of real numbers, right? So we can include x is equal to 1, right? And we have said in the second point that x should be greater than 0. It means x cannot be a negative number. So we can discard this interval also, that is from minus infinity to 0, right? And so we are left with only this interval, that is from 1 to infinity. 1 is included here, right? So the domain of this function is given by this interval, that is from 1 to infinity, where 1 is also included because log of greatest integer of 1 is defined. So the domain of f of x is given by this interval 1 to infinity, where 1 is included, right? So this is how by making these arguments and these discussions, we can arrive at the domain of given functions. Hello viewers, in today's session we are going to discuss an important and conceptual problem from domain of functions, right? And in this class we'll solve this problem in which we have to find the domain of this function f of x involving the inverse trigonometric functions, right? So here we have f of x is equal to tan inverse square root of x divided by sine inverse x minus 1, right? So here we'll see how we can find out the domain of functions by using the concept of intersection of domains, right? So let us start. So here we have the quotient of two functions, right? Tan inverse square root of x and sine inverse x minus 1. So let us first see the domain of tan inverse square root of x. So here we have tan inverse of square root of x, right? Now see, from inverse trigonometric functions, we know that the domain of tan inverse theta is the set of all real numbers, that is theta belongs to the set of real numbers. So whenever we have tan inverse theta, then theta takes all the real numbers. Now here we have for theta we have square root of x, right? And since here we have the square root of x, so the this quantity x has to be greater than 0, right? Because x cannot be negative here, because when we have a negative quantity inside the square root sign, then we have a complex number. So here the domain of tan inverse square root of x is x greater than 0 or equal to 0, right? So here x can take all the positive values or the positive real numbers, including x is equal to 0. So the domain of tan inverse square root of x is given by x greater than or equal to 0, which can also be written as x belonging to the set that is 0 to infinity, right? Okay, now let us come to sine inverse x minus 1. Now let us consider the function that is sine inverse theta. Now, when we have sine inverse theta, then this theta must belong to the interval that is minus 1 to 1. That is, theta must be greater than or equal to minus 1, but it is less than or equal to 1. So here, for theta, we have x minus 1. So let us substitute theta is equal to x minus 1 in this inequality. So we have minus 1, and here we have x minus 1, and here we have 1. So now solving this inequality by adding plus 1 throughout this inequality. So we have plus 1 minus 1. Here we have plus 1 plus x minus 1. And here we have plus 1 plus 1. Right? So here 1 minus 1 is 0. And here we have 1 and 1 get cancelled. So we have x. And here we have 1 plus 1, 2. Right? So we have this inequality, right? And here there is one important thing to note. See, sine inverse x minus 1, it appears in the denominator. And whenever x is equal to 1 or x minus 1 is equal to 0, then we have sine inverse 0 is equal to 0, and we have a 0 in the denominator. And in that case, the function f of x is not defined, right? So apart from this inequality, this sine inverse x minus 1 should not be equal to 0, right? So for this, x should not be equal to 1. So incorporating these two, the domain of sine inverse x minus 1, which appears in the denominator of this function f of x, we have x greater than or equal to 0 but less than or equal to 2, including x is not equal to 1. So now let us call the domain of tan inverse square root of x as d1, and the domain of sine inverse x minus 1, which is given by these two expressions, let us call it d2. So the overall domain of the function f of x is given by say d is the domain of f of x. So d is given by the common region between d1 and d2. So we have the intersection of d1 and d2. So to identify the common domain, we have to take help of the real number line. So let us draw the real number line like this. So here we have minus infinity, here we have plus infinity, and let us take here the point 0, and then we have 1, here we have 1, and then let us take here the point 2. So now the domain D1 is given by x greater than or equal to 0, right? So we have this region, that is x greater than or equal to 0 is given by this region. So here this 0 is included. So here we make it dark, and then we have x greater than or equal to 0 but less than or equal to 2, right? So we have like this, and from 0 to 2, and here we have 1, right? And 1 is not included, so we'll make a circle here. So this circle indicates that this x is equal to 1 is not included, right? And here both 0 and 2 are included. So now the domain D is given by D1 intersection D2. So D1 is x greater than or equal to 0. It means D1 is given by this interval, that is 0 to infinity. So here 0 is included, right? And then we have the intersection, and then we have D2. So D2 is from 0 to 2. So first we'll write here 0 to 1. So 0 is included but 1 is not included, so here it is open, right? And then we have union, and then here we have 1 to 2, right? 1 to 2, and 2 is included, so here we have a closed interval. right? So D1 intersection D2 is given by this notation. So now the common region between these two domains, this is D1 and this is D2. So here the common domain is this region, right? From here to here. So from 0 to 2, we have the domain of f of x, excluding this x is equal to 1, right? So the intersection of these two intervals is now given by this one, that is 0 to 1, and here 1 is not included, and then we have the union, and here we have 1 to 2, and 2 is closed. So the domain of this function f of x is given by 0 to 1, from 0 to 1. 1 is not included, 0 to 1, 0 is included, and then from 1 to 2. From 1 to 2, 1 is not included, and here 2 is included. So the domain of f of x is given by the union of these two intervals. So we can also express this notation like this. We can take the entire interval from 0 to 2, that is 0 to 2, and then we can exclude 1 from this interval, right? So we can also write here 1 in the curly brackets. Hello viewers. In today's session, we are going to discuss another important and conceptual problem from domain of functions, right? So here we have to find the domain of this function f of x, which is the sum of inverse trigonometric function and the square root function, right? So here f of x is equal to sine inverse x plus square root of x minus 1 over 2, right? So we have to find all the values of x for which this function f of x is defined, right? So let us start. So let us take this function as g of x, and let us take this function as h of x, right? So here f of x is the sum of g of x, which is sine inverse x, and h of x, which is square root of x minus half. So whenever we have a function which is described as a sum of two functions, then to find out the domain of that function, which is f of x, what we do, we find the domain of this function g of x. So let us denote the domain of g of x, which is sine inverse x, as d1, and let us denote the domain of h of x as d2, right? And let us take the domain of f of x as d. So the domain of f of x is given by the common values of x, which satisfies sine inverse x and square root of x minus half simultaneously, right? So first we'll do or we'll find out the domain of this function, then we find out the domain of this function, and then we'll take the intersection of these two domains, right? So this is the concept behind finding out the domain of a function which is expressed as a sum of two or more functions. So now from the inverse trigonometric functions, we know that sine inverse x, it belongs to the interval that is from minus pi by 2 to pi by 2, right? And whenever this x belongs to this interval, that is minus 1 to 1, right? So the domain of sine inverse x is given by this interval, which can also be written like this: x is greater than or equal to minus 1, but less than or equal to 1, right? So d1 is given by this inequality, right? Now let us find out d2. Now here we have the square root function, and anything which is inside the square root function has to be positive or equal to 0, because here x minus half should be greater than or equal to 0, because we cannot have a negative number inside the square root sign. So in that case, the number does not belong to the set of real numbers, right? So for x minus half to be positive, it should be greater than or equal to 0. So we can take x greater than or equal to half, right? So d2 is given by this inequality, and this inequality can also be expressed like this: x belongs to the interval that is half to infinity. So once we get the domains D1 and D2, the next step is to represent these domains on the real number line, right? So let us take this real number line. Here we have minus infinity, here we have plus infinity, here we have minus 1, then 0 and 1, right? And this 1 over 2, that is half, it lies between 0 and 1, right? So here we have half. So now d1 is from minus 1 to 1. So here we have d1 and including both these endpoints, right? So this is our d1, and d2 is given by this interval that is half to infinity. So here we have half is included here, and we go like this, right? So this is our d2 from half to plus infinity. Now we have to identify the common region which is lying between these two domains, that is d1 and d2. And from this representation, we can easily see that this region, that is from half to 1, right? So this part is common to both these domains, right? So d can now be written as from half to 1, right? So half is also included, and here 1 is also included, right? So the domain of this function f of x is given by this interval, and that is from half to 1, because this region is the only region which is common to both these domains, d1 and d2, right? Because this part that is from 1 to infinity is not included in d1, and similarly we can explain other regions also, right? So our required domain is given by this interval, which can also be written like this: x is greater than or equal to half, but less than or equal to 1.